All right, so now we're going to start looking at the standard form of a complex number. The standard form is a plus bi. So we're actually going to take and just kind of work with, reduce, and play around with the standard form. So we have 2 plus the square root of negative 9i. All we're doing is taking and reducing this down so that it's in a simplified form. So we have the 2, which we're not going to do anything with. It's actually the square root of negative 9 that we have to play around with. The square root of 9 obviously is 3, and that negative means that it's going to be an I. So I know that it's going to be a plus 3i. You might have the urge to put plus or minus, but because the original equation already had a plus in it, we're just going to deal with the plus. So again, for b, we have 5 minus the square root of negative 18. Well, 5 minus, we're going to go ahead and pop out that negative and make it an I. And we're going to break down that 18. I know that it's 9 times 2. So the only thing I can take the square root of is 9. So I get 5 minus 3i with the square root of 2 remaining underneath for my final answer. All right, so now we're going to perform addition and subtraction. Okay, addition and subtraction means that I'm just going to make sure that I only combine my like terms. All right, we did this with our x's and our y's, and the same exact thing applies for our i's. So if we notice, between my parentheses is a plus, so nothing is changing nothing is changing inside of my parentheses. So I'm going to just combine like terms. By the way, when I write my answers, my i's are always going to be my last term. They're not my first term. They are my last term in this case. So I have a 2 and a 5. I'm going to add them together to get a 7. Then I have a 4i and a negative 3i. Well, 4 minus 3 is just a 1, but I don't need to write my 1, but I know that it's going to be a minus I. Oh, sorry, plus I. 7 plus I. 4 minus 3i is a positive I. Now for my second one, I have a minus between them, so I know that I'm going to have to distribute that negative. So I'm going to have an 8 plus I with a minus 1 and a minus 6i. Again, combine my like terms. 8 minus 1 is 7. I minus 6i, so that it's basically like saying x minus 6x. So this is going to end up being a minus 5i. All right, for 6, we're multiplying our complex numbers. This means that I'm going to have to do exactly like I did for any other binomial. I'm just paying attention to my i's. So first one, I multiply 3 times 7, which is 21. 3 times a negative I is minus 3i. Then I'm going to multiply 2i and 7 to get positive 14i. And then 2i minus I should get a negative 2i squared. Now if you remember, I squared is the same as negative 1. Oops, I don't have to put that in parentheses yet. It's the same as a negative 1. So when I go to combine like terms, I have a 21. Negative 3i, 14i makes that a positive 11i. And then I have a negative 2, and instead of I squared, I'm going to change that to a negative 1. So I'm not done simplifying. I have a 21 plus 11i. But that negative 2 times a negative 1 becomes a positive 2. And then I'm going to combine two more like terms to get a 23 plus 11i as my final reduced answer. All right, B. We have 4 plus I, 4 minus I. This hopefully will look familiar to you. This, if you kind of look at the side, it's kind of like saying 4 plus x, or sorry, yeah, 4 plus x, 4 minus x. And if we remember, this is a difference of squares, so I should have two terms that cancel out in the middle. So distribute my 4 and I get 16 minus 4i. Distribute the I and I get plus a 4i. Positive I, negative I, I get a negative I squared. Well, my two terms in the middle cancel each other out, so I get 16 minus, remember that I squared becomes a negative 1. That becomes a 16 plus 1, which gives me an answer of 17. So when you're doing these, you're going to have one extra step at the end where you have to change your I squared to a negative 1. It's very important that you are careful when you plug things in. Make sure that you are using your parentheses. All right, so now a plus bi and a minus bi are opposites of each other, and they are conjugates. So now we're going to actually be dealing with complex conjugates. So it says for 7, it wants us to write the complex conjugate of the complex number, and then we're going to multiply the number by its complex conjugate. Okay, so that's a mouthful. So really all we're going to do is we're going to take that 9 plus I, and we're going to multiply by its conjugate, which is 9 minus I. So we're going to multiply it out. We should get 9 times 9 is 81. 9 times negative I is minus 9i. Multiply I and 9 to get a positive 9i. Negative I becomes a negative I squared. These two things cancel each other out. Anytime you're multiplying by its conjugate, the middle term should always cancel out, so that you get 81 minus, instead of I squared, I'm going to place my negative 1. This becomes an 81 plus 1, which of course is 82. Now, for 8. They want us to factor over the real numbers, and then we're going to write the factored form of our f of x and its real zeros. So we're going to factor, we're going to write the factored form, and we're going to give the zeros. Okay, so multiple parts to our answers. All right, so A. Well, this is just an x squared, so I know I'm going to do, well, what times what gives me negative 99 and adds to be a negative 2. Well, 99. I have 11 and 9, so it has to be a negative 11 and a positive 9 to give me a negative 2. So I get x, sorry guys, I get x minus 11 and x plus 9. So factored form is this guy here. My x's, of course, if we know by now, I shouldn't have to work these problems for you. You should know that you're shifting 11 to the other side, so your answer is a positive 11 and a negative 9. And these are the two answers that they asked for: the factored form and the zeros. All right, so now looking at B, I have 4 terms, so of course I'm going to group the first two, the last two. I'm going to take out my GCF, so I'm pulling out a 4x squared. And we don't like negative terms, so I know I'm going to pull out a -1. So I get a 4x squared out front. Do my division, and I have an x minus 2. Pull out the -1, and I'm left with an x minus 2. Remember, once those two are the same, you're good. You get 4x squared minus 1 and an x minus 2. Now, I have an x squared in that last set of parentheses, so I need to double check. Is it a difference of squares? In this case, it is. So I know I'm going to factor it one more time. And I know that I'm going to get a 2x minus 1, 2x plus 1, and bring that x minus 2 down. This is my factored form all the way down to all of its factors. And my x's, of course, is going to be a 1/2 plus or minus 1/2 for those first two, and then a positive 2 for the second one. If you don't know how I got that, I get 2x minus 1 equals 0. You add the 1, so you get 2x equals 1 divided by 2. So you get x is 1/2. And of course, I have a plus and a minus of that one, so it's going to be a positive and a negative. So this is also part of my answer. All right, so part C, x to the power of 4. This one is just going to be kind of like the previous ones. I just know that I'm going to have x squareds inside my factors. So I just have to figure out what times what is 6, but adds to be a -5. Factors of 6 are 6 and 1. So positive -6, sorry, positive 1, -6, positive 1. So that I get x, oops, sorry guys, x squared minus 6, x squared minus 5. I am wrong. I'm wrong. Ha ha ha, I can admit when I'm wrong. Factors of 6 are 2 and a 3. So we need a -2, -3 to give me a positive 6, and a -2, -3 to give me a -5. Haha, caught my problem. So I am left with an x squared minus 2, x squared minus 3. I cannot take the square root of either one of those things, so that is actually my absolute final factored form. But I need to solve those, so I know I'm going to have to do x squared minus 2 equals 0, and x squared minus 3 equals 0. Add my 2's to get x squared equals 2. Well, to solve that, I have to take the square root, so x is equal to plus or minus 2. So, of course, if that's x equals plus or minus 2, this one is also going to work out the same way. Take the square roots. X is also going to be plus or minus 3. So, I have my factors, and I have my zeros.